place to come back to the synthetic LBD paper. And I mean, again, the methodology that I prepared, I mean, the different models and stuff mostly just came from that paper. I mean, some kind of like modifications to those. So I hope you still like remember what that synthetic LBD was doing. And this were the discussion questions. I think we already sort of covered at least one, right? Remember like that table that we looked at? I think, yeah, I should put the paper. If you have the paper with you, feel free or like just put it up. But from that table that we have, I think all of the Y's, when they use the index, like the first year, right? First year, last year, multi-unit status, employment and payroll, those are the synthesized variables. And then the unsynthesized, I think they have a few, like the SIC, I think is the industry code, right? Yeah, so those, yeah, that is the X, yeah, that's X2. X1 is county, so they don't actually release it at all. Like they use it in the synthesis model, but they don't release it. So I think for number one is okay. Two, we also talked about last time when you have more than one variables to synthesize, you just do it sequentially. Okay, you have to, well, figure out in what way you want to do it. So for now, let's just have a short discussion with your neighbor for the other questions I put it up here. Maybe focus on 3, 4, 5, because well, number 6 about disclosure risks. I mean, we can come back to this when we get to that section about how to evaluate risks. But for now, I think it's useful to review and discuss like the different synthesis models that they use. And also, based on your reading of the paper, how many synthetic data sets do they generate? Like, what do you think? And lastly, like, how do they evaluate the utility? Okay? And can you think of any other utility measures, especially given that we have read the other paper, the Wu et al. Paper in 2009, right? That's where we saw some global utility measures that you can use. And okay, so let's spend the time for you to discuss with the neighbors on questions 3, 4, 5. Okay. All right, I think I was trying to capture constantly everybody together. And yeah, so just, yeah, I'm just using the computer. It's easier to scroll down, like, oh, I'm just saying that like we can start maybe like discussing it as a class. And so we're trying to figure out like what kind of models they use.
Goodbye, I'll call you later.
And then how many synthetic data sets they used. Sorry about that. Yeah. And then the utility, what kind of utility measures that they develop. So like I have the paper here, I mean on the screen. So if you want to like offer what you think, let me know on what page I should be coming to, that we can talk about what you have found out. So maybe the easiest one first. How many synthetic data sets do they generate? One, right? They only release one copy. So, and I think that's what they say. Let's see. I think yeah, it was somewhere. I think they say, right, so it's on this section 3. For this initial version of the SynLBD, we generate a universe file comprising one record for each of the 21 million establishments. Yeah. So given that, I think what they mean is that they're only generating one, and then that's the one that really, okay. So I think that part of the question is okay. And what about the models? Like, do you have questions? Like, they brought up a lot of, I think, new terminologies of how they exactly did the prior. For example, they talked about, what was it? Confidentiality prior, things like that for synthesizing like first year. And I mean, that's the first one. That's Y1 they're doing. And then there are many other like details, I think, goes into all of those synthesis models. So my take on this is that definitely once, I mean, especially if you start doing your own project, you might get into, I wouldn't say issues, but you might start to realize you have to play with the model a little bit. And I think all of the added stuff that they talk about is probably very specific to the data that they work with. So I think for us, I mean, the biggest takeaway is, well, we have continuous variables. You can use some kind of normal regression. when you have categorical variables, you can either use durational multinomial or the multinomial logistic regression. And then we have binary. So in their example, I don't think they have any binary, but I included that in the lecture that we had. So my take away of this is, yeah, like it really highly depends on the application. And I mean, actually, you will also, I'm sure you're going to share when you're looking at the utility evaluations, how they're doing it. It's also very application specific, right? I don't think they talked much about any of the global utility measures that we saw in the other paper. Everybody agrees on that? So anybody wants to talk, I mean, I guess just like pick a few that you think are interesting in terms of the utility that they do. And if you want to also just keep comments on like, oh, do you think on that utility measure that the synthetic data is doing well or actually doing not well? Any comments is welcome here. What do you think? Like what jumps out from their utility evaluation that you think is very interesting, that, or I should say, it might be something that you might want to borrow when you are trying to evaluate the utility of your synthetic data once you get to that point for your project. Like anything that you find interesting enough or useful enough that you might want to remember for your project. Anyone? So on the page, on section 4, the entire section is about analytic utility. Yeah.
On page, I need like 370, for example.
370.
Like when they gave these graphs, I think it would have been nice to see the actual numbers behind, like how far off of the line
Oh,
the
I see.
synthetic and original. Because sometimes they look like exactly the same data point, like not changed. But I don't know if that's just because of the scale used or something.
Yeah. So yeah, good point. So let's see. So figure 3 and 4, they are the like share of employment and share of payroll by industry, sector, and year. So I think yeah. So the variable they're evaluating is the employment and the payroll in the two figures. So Kevin's point is yeah, like so using the 45-degree line makes sense. Like we want to see how close they line up. I mean, because the x-axis is the original, the y-axis is the synthetic. So if they're closely lining up with that line, then that means high utility, right? So Kevin's point is, I guess you're talking about whether we can add maybe some more information about like how deviate each point from that line. Okay, yeah, good point. I mean, for this, I mean, from this plot, I don't even know how many dots are there. I mean, definitely not like 21 million. It must be a particular, I don't know, because if it's share of employment by the different sector, like the by sector and year. So I think the number of points is probably how many combinations of the sector and year there exist, because each dot should represent a share of employment for that combination. So maybe that's why, but yes. So when you don't have like a lot of dots, or like even for this reasonably like reasonable number, then you can maybe like label that like in terms of the deviance that you have from each other. That would be good. Any other comments? So you see that this kind of 45-degree line is very commonly used. Like pretty much all of the like the share, like the bisector and year thing that they did is always, I mean, by this nature. And they also did like later figures like 5 to 7. I think they did the share of the different continuous variables by state and year. So state again is the count. I think it's derived from the county variable. So they say that they never release it, but they use it in the synthesis model, I think. So that's another thing, I guess. So this type of stuff will be, others cannot evaluate this because, I mean, the county label or like the state was never released. So when you're evaluating this, it's more of a report from people who actually have the data, so they're able to make statements about this. So there, I mean, probably larger deviation here when you're dealing with the state level and stuff. Anything else? I can go to any page that you want me to go to, and then we can get back.
Figure 8 was interesting because it was like the big. deviated a lot.
Yeah, so I think good point. So when I was reading this, I made a note that whether this means it's a good synthetic data or not in terms of the utility. So this is the job creation rate by year, and I mean, it's like 30 versus 20, which is a big difference. I think they talked about some reason why that is the case, especially just it's just like right below here. So that's the thing. Sometimes, I mean, you can see how certain, I mean, I'm not like saying it's not good, but a lot of times when you do application kind of work, if you see some kind of results like this, you try to justify why that is the case. So no model is perfect. I think they're trying their best, and like a decade ago working on this, so they provided some reasons. And I think many of this will be very specific to the application. Like we need to understand it well enough to see, like, first of all, I think they came up with all of those different like the ways to evaluate. I think that definitely, like, I think they refer to some kind of economics theory and all that. So I think a big takeaway for us is, especially when you're doing your project, you want to understand the problem to extent that you are able to come up with some very analysis specific utility measure, because that, I mean, there are many caveats here and there, like whether you should use this one, not that one. But at least I think for your project, you should try to pick a problem or a data set that you really care about, and then you have some interesting, I guess, analysis question you want to do, and then those will they can be easily turned into those utility measures. Okay, and then a lot of times I think that's exactly what people do. Like you can develop models, but then for evaluation you have to be like into the problem and know what you want to do. Yeah, Maggie?
Yeah, I was just looking at figure 8, and I'm wondering if they, like, this results from them like generating first year, like at first, and then like somehow like creating a different kind of like a parallel universe where things happen at a different time, but then they follow this kind of similar trends, and then like the data hackers do not know how to have more identification issue, but like for researchers, it might like probably still be some utility because you still have the trend.
Right, good point. So yeah, so if we look at like say figure 8 again, it's not good enough because we have this gap, right? But then if you look at the trend, I mean, again, this is like job creation rate by year going through the entire period of what the data was about. The trend is pretty much pretty well preserved. I mean, especially like the big jump, right? And then the big decrease, those ones. But Maggie mentioned an interesting point, which I actually personally don't know too much about in terms of this research topic, is we know that you have to do sequentially when you have multiple variables to synthesize. But what will be the right order, or if there is this like particular order that you should go from? And I don't know much about it, but you might want to explore that when you're doing your project, and you might find some insight from there. So what Maggie was trying to say, that it may be because not like the paper, those people, they were doing the first year first, and then, well, this is job creation rate, so I don't know for sure, but it's possible that like the order going to affect certain outcome. And then for complicated data sets like this, it's very much like the case. Okay? So that will be another argument, like a counter argument of why we had the discussion last time that like the pros and cons of sequential modeling and the joint modeling, right? Sequential is like easy. You're dealing with like univariate every time. You're always doing the conditional in some sense. But at the end of the day, the sequential is trying to approximate the joint, okay? It might be a good approximation, might not be a good approximation. But the cons of the joint is that you never know if it's going to follow the joint in the first place, and then it could be complicated. So, but the truth is, for sequential synthesis model, it is pretty challenging to figure out what will be the right order, and then that might be something you want to explore when you get to your project. Okay. Anything else? They did a regression analysis. They wrote down whatever the model is. What I found interesting is how they present the result. And I think this is, so it's figure 11. And it might be useful for some of us in terms of what you're going to do for your utility measure for your project, or even so for like a practice doing the CE synthesis if you want to do that. Because this is, I think they run a regression analysis and then they are labeling like a different regression coefficient, right? So they still have this like 45-degree line, so it's everything close to that line will indicate a good, I wouldn't say good match, like a high utility for that particular coefficient. But I think here they're able to put everything together in some sense that you can see it. Because another way to present this results, you probably have seen, yeah, so in the intro lecture that I show you tables of like what will be the regression coefficient estimate in the synthetic data, what will be the regression coefficient estimate in the original data, and then the 95% credible interval, all kinds of stuff. So you can also use a table to show results like this. But if you have a lot, like say in this case, I think they have a lot of regression coefficients to show, then a plot like this might be useful. So this is like, I think, pre-ggplot era. So nowadays we probably can even make even like fancier plot with different coloring and all that. This one's slightly hard to read, I think, in terms of yeah, which one is about which. But I think this will be something useful if you later going to do a big regression analysis, including a lot of coefficients, then using a graph, comparing to use a table, maybe use a visualization like this might be good. Okay, all right, okay. So I think that would be it for what we have for, let me just close this, what we have for this discussion. And yeah, so